Hello, and welcome to this class. I am Ngobani Kestin, and I'm going to be taking you on the subject, chemistry. The theme of our class is chemistry and environment, and our topic is water. We're going to be taking the first part of this topic. At the end of our lesson, you will be able to draw and explain the structure of water, explain the causes of hardness of water. You'd also be able to explain the methods employed in the removal of hardness. Then you'd be able to explain the methods used in purifying water. Water makes up over 70% of the Earth's crust, and it's one of the most abundant raw materials used by man. It forms most of the world's rivers, streams, lakes, oceans, and seas. Water is assumed to be transparent, colorless, and odorless, although it rarely occurs in its pure form. Water has countless uses. For human beings, we drink water, we cook and wash with it, we fish and swim in it. For animals, they also need water for their survival as they drink it. Plants also need water to grow well. Do you know that water constitutes the major element in the fluid of living organisms? In fact, water constitutes over half of the internal makeup of human beings. So you see that the uses of water are endless. Now, how does water look like? This takes us to the structure of water. The water molecule is made up of two atoms of hydrogen and an atom of oxygen that are bonded together covalently. And it is written as H2O. This is derived from the two elements that make up water, which are hydrogen, written as capital letter H, and oxygen, also written as capital letter O. Now we say that it is made up of two atoms of hydrogen. So this hydrogen would carry 2 as a subscript. So this is the way we write water anywhere in the world. You can see water can also be represented in these ways. This simply shows the structure of water in the form of a diagram. Here we have one atom of oxygen with 2 atoms of hydrogen. This also represents this, and we can also represent it this way. In any way you choose to draw the structure of water, it must contain 1 atom of oxygen and 2 atoms of hydrogen. Water naturally exists as solid, that's ice, liquid, and gas. As solid, we can see naturally occurring water in the solid form in places we call solar ice caps. The liquid form of water, of course, is the one that's available to you and I to drink and use at home. The gaseous form of water is also available to us. You know, when you boil water and you see water vapor coming off when the water is boiling, yeah, that's water in its gaseous form. That's steam. So these are the various ways that water occurs naturally. Now, I don't know if you've noticed, but have you noticed that sometimes when you wash with soap, okay, the water does not readily form lather with the soap? Actually, when I was younger, I used to wonder why that was. You know, sometimes I wash and the water is forming enough foam with my soap. At other times, it does not. Well, I know the answer now, and that I'm going to share with you. That phenomenon is what we call hardness of water. And this hardness of water is a condition in which water contains high amount of some dissolved mineral salts, which would not easily allow the formation of lather with soap. So, remember we said earlier that water rarely occurs in its pure form. So what causes hardness of water is that there are some dissolved minerals in the water that makes it unable to form lather or foam with soap. Now, these mineral salts are salts of calcium and magnesium, and they are specifically calcium tetroxysulfate 6, written in this way, magnesium tetroxysulfate 6, calcium tetroxysulfate 6 is written this way, magnesium tetroxysulfate 6 too is another cause of water hardness. Then we have calcium hydrogen triisocarbonate 4. Now what happens is that when you try to wash with soap, the dissolved salts in the water interfere with the soap in this way. Okay? Here we have dissolved, for example, dissolved calcium or magnesium salts, soluble. It's in water actually. Then when it reacts with sodium octadeconate, otherwise known as soap, what happens is that there is an exchange of ion. The calcium combines or binds with the octadeconate of the soap to produce what we call scum, which is insoluble. So we say insoluble scum. Okay? Now, this insoluble scum is those whitish particles you see on your clothes when water does not readily form lather with the soap you're using to wash. There are two types of hard water. We have the temporary hard water and the permanent hard water. We are going to be looking at the salts that cause both of them. For temporary hard water, this type of hardness is caused by the presence of dissolved calcium hydrogen triisocarbonate 4, which is specifically this salt. Okay? This causes temporary hardness. But temporary hardness of water can be easily removed by boiling the water. For permanent hardness, it is caused by the presence of dissolved calcium or magnesium tetroxysulfate 6. And this kind of hardness cannot be removed by boiling. So, these first two salts cause permanent hardness of water. Permanent hardness. Okay? While this one causes temporary hardness of water. Okay, so now we have seen the different salts that cause temporary and permanent hardness of water. Now let's just look at the ways we can get rid of these salts from hard water. So we'll be looking at removal of temporary hardness and removal of permanent hardness. For temporary hardness, remember earlier we said that it can be removed by boiling. Okay, so what happens when we boil water is the calcium hydrogen triisocarbonate 4, which causes the hardness, can crumble or decompose when water is boiled. For example, you can see this is a soluble calcium hydrogen triisocarbonate 4. When the water is boiled, it comes out as calcium triisocarbonate 4 with water and carbon dioxide gas as byproduct. So the main thing here is that the calcium ion has been removed from the water. So this water here is what? Soft water. It's no longer hard. So that is one way we can remove temporary hardness. Another way that hardness of water, temporary hardness of water, can be removed is by the use of slaked lime. And here is a chemical formula for slaked lime. So when slaked lime is introduced to this calcium hydrogen triisocarbonate 4, it reacts with it to bring out this calcium ion in the form of calcium triisocarbonate 4. And the water produced here is now soft water because this calcium ion has been removed from the water. So these are the two ways that temporary hardness of water can be taken care of. For permanent hardness of water, we say that it cannot be removed by boiling. The only way we can remove permanent hardness is by the use of chemicals. And these chemicals are washing soda, caustic soda, perlmuttite, or zeolite. But we'll be looking at the first two chemicals. The use of washing soda, this is washing soda. When this chemical is added to water containing this dissolved calcium tetrasulfate 6, it reacts to bring out the insoluble calcium trisulcarbonate. Okay? Also, when this chemical, caustic soda, which is this, is added to water containing any of them, either magnesium or, remember we say that it's salts of calcium or magnesium that can cause this hardness. So whether it's calcium or magnesium tetrasulfate 6, okay, if they are present in the water and you make use of caustic soda, you add this chemical, caustic soda, to the water, it helps to bring out the iron. Here is the magnesium ion that is being brought out from the solution. And so the water becomes soft. So these are the ways we can remove hardness of water. But then, there are some good uses, some advantages of water hardness. These advantages are, some of them anyways, they are, 1, the presence of these dissolved minerals in hard water makes this kind of water taste better than soft water. Have you noticed sometimes when you drink water, it's like the water has a nice taste and you're enjoying yourself? Yeah, it's because of the presence of these minerals in the water that makes the water taste good. Remember that pure water is supposed to be tasteless. So when it has tastes, it may just be because of these dissolved minerals in the water. 2, the calcium salts or magnesium salts in hard water help in the building of strong bones and teeth in animals. 3, the calcium trisulcarbonate 4, remember the one that comes out as a byproduct of the removal of hardness of water, okay? This is actually limestone, okay? And it is used in the making of shells in animals such as snails and crabs. So this is useful for animals like snails and crabs. It helps their shells to be quite strong. 4, unlike soft water, hard water does not dissolve lead pipes. Therefore, it does not cause lead poisoning. Soft water dissolves lead pipes. I know that when there is lead in the water you drink such water, it leads to what we call lead poisoning. Lead is a very, very dangerous or harmful chemical that must not get into our body because it's harmful to our health. Salt water dissolves lead, which leads to lead poisoning in our bodies. But the good news is that hard water does not dissolve lead pipes. Now let us look at some disadvantages of hard water. 1, hard water is wasteful as a large quantity of soap is used up during washing. You notice that when you make use of water that does not easily form lather with soap, you find out that you're using more soap because you're trying to achieve lather. So you're making use of more soap to wash. At the end of the day, you realize that your soap is finished just because you want to wash. So that is what hard water does. It makes us use up more soap during washing. Hard water causes the thawing of kettles and boilers due to the calcium trisulcarbonate 4 formed or deposited during boiling. Take up your kettle in the kitchen and look inside. You're likely to see some whitish substances, fur-like substances, deposited around your kettle or in your electric boilers. Those things are what we call thawing of the kettles, and they were caused due to, repeated use of the kettle in boiling hard water. Another disadvantage of hard water is that it cannot be used in some chemical processes because the salts are always interfering with these processes. These are mainly processes that require high level of purity. So hard water is likely not to be used for such activities. Example, tanning and dyeing. This is what we have on hard water. Water purification refers to all the methods employed to make water suitable for human consumption and for domestic use. Remember, we earlier said that water hardly occurs in its pure form. So before we get the water we use at home, it would have undergone some processes of purification before they get to us. So those processes are actually there to make water suitable for us to be able to drink and use for other domestic purposes like washing and cooking. So we say that the process of purification involves the removal of several unwanted substances, such as unwanted chemicals like lead, bleach, pesticides, etc. These are harmful to us, so they need to be removed. Biological contaminants, example, bacteria, virus, fungi, etc. Suspended solids. Yeah, there are some solids that dissolve in water. Example, metals, salts, even soil particles, etc. Then gases. Gases also dissolve in water. And some of them that need to be removed are carbon monoxide, benzene, nitrogen, and other harmful gases. So water purification involves the following stages. We have coagulation. This simply means the introduction of some chemicals like potash alum or sodium aluminate 3 to cause the impurities to stick together to form clumps. The next stage in water purification is sedimentation. This is the settling of the clumped particles or impurities at the bottom of the vessel or container. So those big lumps of impurities settle down, sediment at the bottom of the vessel, and they can be removed. After this stage of sedimentation, the next thing is filtration. This is important because there are still some fine particles that won't go off after sedimentation. So filtration is the passing of water through a filter bed to remove any remaining fine particles still present in the water. After filtration, we have a supposedly clear water. But remember, germs in water cannot be seen with the naked eyes. And so, in as much as the water looks clear, it doesn't mean that it is still fit for drinking. Okay, so the next stage is disinfection. This means the use of chemicals such as chlorine to treat the water in order to kill the unseen germs. So these are the stages in water purification. Other methods available for water purification are boiling. You know what boiling is? It just means boiling the water, okay? Now, boiling is good because it removes most of the germs in water. But one disadvantage of boiling is that some impurities that have a higher boiling point than water may not be easily removed through boiling. In fact, boiling may actually increase their concentration because remember that when water boils, some water escapes as gas, so we have less of the water. And having less of the water means that such impurities that we're not able to leave through boiling would be more concentrated in the water. Distillation. This is another good method for purifying water. But one thing with distillation is that distillation makes water so pure that there are no impurities, minerals, or any other substance that can be found in water. But then, potable water sometimes needs the presence of some healthy dissolved minerals. Then desalination. Well, this method simply is used to turn salt water to fresh water. These and many more are the methods used for water purification. You can Google and find out other methods available. Now, municipal water. Municipal simply means, community or town. And municipal water supply refers to the supply of treated water to the community or the public. So the water you have available in your homes for drinking, washing, bathing, they did not just come like that. There was, there are stages of treatment that this water would have gone through before it came into your home. So we are going to be looking at some of the treatments given to community water. So that the major source of municipal water is pipe-borne water. And usually they are stored in tanks such as this, and we can get them through taps or through our showers. Now, the treatment of municipal water involves the following process. First, there is a pre-treatment that the water has to go through. Water from underground, rivers, lakes, etc., is collected in a reservoir and stored. There are actually two sources of water. We have underground water sources and surface water sources. For surface water, it has to do with all the water bodies that are above the surface of the earth, like your stream, your rivers, lakes, ocean bodies. These are all termed surface water because they are above the surface of the earth. Underground water is the water we see or we get from under the earth, okay? And the major source of underground water is rain. When rain falls, it goes under the ground and collects there. So these are ways that water is made available to us, underground water and surface water. It doesn't matter whatever means they come from, okay, whether under the ground or on the surface. But the most important thing is that they are collected in a reservoir and stored. And some pre-treatment is given to such water. Then after this, then we go through the normal process of coagulation, sedimentation, filtration, and disinfection. So we have coagulation here. The untreated water is passed through large tanks where chemicals such as potash alum or sodium aluminate 3 are added to cause the impurities to clump together. After coagulation, remember we mentioned sedimentation. Remember we're talking about municipal water, how the water is treated before it comes to our home. Okay? Next one is sedimentation. These clumped impurities form big particles of dirt or flux, which settle down very rapidly to the bottom of the container or the vessel. Next is filtration. The water is passed through a filter bed to remove the remaining fine particles that are still present in the water. Having done this, next is disinfection. Chemicals like chlorine are used to treat the water in order to kill germs. Now, an additional treatment is given to water when it is already clear and germ-free. Useful chemicals like iodine and fluorine are added in their right amounts to this treated water. These chemicals are important because they serve as food supplements to help prevent goiter and tooth decay, respectively. Okay? Iodine helps to prevent goiter, and fluorine helps to prevent tooth decay. So you see why healthy water that's, it's suitable for human consumption does not come as 100% pure water. Some of these dissolved minerals are actually healthy for our body. Finally, the treated water, which is now clear and germ-free, is stored in a reservoir and then passed through underground pipes to be used by the members of the community. So this is how community waters are treated before they get to us. Now we'll be looking at distilled water. Distilled water is water that has had all of its impurities removed through the process of distillation. In fact, distilled water is like, let's not say pure water, but it's like 99.9% pure water because all the impurities, whether good or bad, has been removed from the water through this process of distillation. So we say that distillation removes all minerals and other dissolved particles from water. Now, distilled water is prepared by, it just has a very simple process, boiling the water and then condensing the steam into a clean vessel or container. It's kind of simple. We are going to be looking at how distilled water is prepared in the lab. So we say we have laboratory preparation of distilled water, and we have some apparatus required for this. Well, at the end of learning how distilled water is prepared in the lab, maybe you'll find out that you can actually prepare distilled water at home if you have some of these apparatus or things that can serve in place of these apparatus. The apparatus we need for the preparation of distilled water in the lab are 2 glass jars or beakers with lids. Now, these lids must have openings. Okay. Next one is a long glass tube with openings at the end, a capillary tube, burner. For the lab, we usually make use of Bunsen burner. An utensil large enough to hold glass jars and ice, because one of the apparatus is also ice. This ice serves as condenser. Now, experiment. What we are going to do is that you fill one of the glass jars with ordinary water. So if, say, we have a glass jar filled with water. Now, remember we said that the lid of this jar must have an opening somewhere. Now, you place the second glass jar inside the utensil, or say just a bowl, okay, that is large enough to hold it. So we have another glass jar inside an utensil or a bowl, okay, with a lid as well. But this lid must have 2 openings for a good reason. Must have 2 openings. Okay? But the next thing we do is insert the glass tube through both lids to form a connection between the glass jars. Okay, we have an image here or a diagram representing what we are talking about. So we have, this is the first glass jar, this is the second glass jar, and here is an utensil holding the glass jar, with ice. Okay, in the empty hole of the lid of the second jar, insert a small capillary tube. This is our capillary tube. This capillary tube actually serves as a chimney for some of the steam to escape. Now, what happens is that this glass jar, the water in this glass jar is made to boil. Now, as it's boiling, the water vapor or steam begins to go out through this opening. And then it goes all the way down to the second glass jar. Now, the work of this ice is to provide a cold environment for the steam to come into. Okay? It makes this second glass jar quite cold. And you know what happens to steam when it meets a cold body? Okay? It condenses back into the liquid form. So the idea is to make this environment quite cold so that when the gas or the water vapor comes and goes into this second glass jar, it condenses back as liquid. Now, the liquid you get at this point is what? Distilled water. It's pure distilled water. So this is basically how distilled water is prepared. Okay? Now, this capillary tube, remember we said it serves as a means for some gases or some steam to escape. Definitely not all the steam would come down this way. Some of them would remain on top, and they would need a way of escape. And that is what the capillary tube provides. Now we'll be looking at some of the uses of distilled water. Why is distilled water important? Some of them are: 1, it is used in the laboratory for the preparation of reagents and analytical work. It is also used in certain industrial processes that require high level of water purity. It is used in the making of drugs. It is used to top off lead-acid batteries found in cars and trucks. It is used in some household aquariums. With this, we have come to the end of our class. A quick summary: we say that water is made up of 2 atoms of hydrogen and 1 atom of oxygen. Then we mentioned that the 2 types of hard water are temporary hard water and permanent hard water. We also said that water purification is all the method employed to make water suitable for human consumption and for domestic use. Then we looked at what municipal water supply is. We said that it is the supply of treated water to the community or the public. Some treatments involved are coagulation, sedimentation, filtration, and disinfection. Then, lastly, we looked at distilled water. We said that it is water that has had all of its impurities removed through distillation. Now we'll take a quick test. Temporary hard water is caused by the presence of dissolved dash. A, calcium tetrasulfate 6. B, magnesium tetrasulfate 6. C, calcium hydrogen triisocarbonate 4. Well, if you chose A or B, you are wrong. The answer is C. We say that temporary hardness is caused only by the presence of this salt, calcium hydrogen triisocarbonate 4. Another question: which of the following is a process involved in the treatment of community water? A, distillation. B, sedimentation. C, boiling. Our answer is B. Sedimentation is a process involved in the treatment of community water. Well, with this, we have come to the end of our lesson today. Thank you for staying with me.